Last episode we built target encoding and saw how easily it leaks. Now the numbers themselves are clean, but they are on totally different scales, and that quietly breaks a lot of models. Let's fix the rulers. Look at three telco columns side by side. Tenure runs 0 to 72. Monthly charges runs about 18 to 120. Total charges runs from 0 all the way past 8000. A model that sums weighted inputs or measures distance between customers reads 8000 as 8000 units of importance. It is not more important. It is just measured in dollars instead of months. Normalization, the min-max scaler, squashes each column into a 0 to 1 box. The smallest value becomes 0, the largest becomes 1. Everything else slots in between. Standardization, the standard scaler, does it differently. It subtracts the mean and divides by the standard deviation, so each column ends centered on 0 with a spread of 1. Outliers heavy. Robust scaler uses the median and the middle 50% instead, so a few extreme bills don't drag the whole ruler. Let's scale the three numeric columns three ways and watch what each one does to the spread. First the spine, load, then split train and test, stratified on churn, random state 42, before we touch a single scaler. We grab the three numeric columns and fit each scaler on the train slice only. The scaler learns train's min, max, mean, and standard deviation, never the tests. Then we transform both train and test with that same fitted scaler. Test gets train's ruler applied to it. That is the whole no leakage rule in one line. Print the before and after ranges. Min-max lands everything in 0 to 1. Standard centers it near 0 with std1. Robust centers on the median. The figure draws the total charges distribution raw. Then under each scaler, same shape, 3 rulers. Scaling fixed the rulers. But some of these columns are telling the same story twice. Total charges is almost tenure times monthly charges. Next, correlation and multicollinearity. If this helped, like and subscribe for more.